This is the specialist maths that comes out of 5A, question number 16. Find the coordinates of the nearest point to this point on the line given by this equation. Okay, so this is my line given by that particular equation. And that particular equation is in the direction of D. So that is I minus J plus 2K. And there's a position on this point, which is position P, and its position from 0 is governed by this rule here, which means that R equals 1 plus t in the I plus 2 minus t in the j plus 2t in the k. And that's the description of O to P. The position of any point on the line, and it follows that particular direction. I've got this point here, which is 2, 1, 3. And this point here is the point where I need the nearest point to the line. And the nearest point to the line will be straight there where that's a right angle. So if I get the vector A to P, that's going to be A to 0, then O to P, which will be 1 plus t minus 2 in the I, plus 2 minus t minus 1 in the j, plus 2k minus 3 in the k, which is t minus 1 in the I, plus 2t, sorry, that's minus t, 1 minus t in the j, plus 2k minus 3 in the k. So that's the vector which is A to P. I'd like to find out when point P is in this position here so that this distance is the shortest possible distance. And that will happen when this vector and this vector are at right angles to each other. Therefore, I minus j plus 2k dot AP equals 0. So 1 times this is t minus 1 times this, which is 1 minus t, plus 2 times this, which is 2k minus 3, has to equal 0. So what I'm doing is I'm setting up my vector from O to P, which describes all of the positions on this particular line. So then I'm getting an expression from the point that I want to the line by going from A to P. And that will vary as P changes. So I'd like to find when T is. So I'm going to have T minus 1 plus T plus 4T minus 6 equals 0. And that gives me 6 T's, and minus 8 equals 0. Therefore, T equals 4/3. That's the value of T when P is here. So if I want to know the coordinate of P at that particular point, I would put into R T equals 4/3. And that would be 1 plus 4/3 in the I, plus 2 minus 4/3 in the J, plus 2 lots of 4/3 in the K, which is 3 plus 4, 7/3 in the I, 6 minus 2 plus 2/3 in the J, plus 8/3 in the K. And if that is the position vector when T equals 4/3, the point, and I've been asked to find the coordinates, will be 7/3, 2/3, and 8/3. And that's question 16 out of 5A.